Okay? First concept. Two matrices that are equal. Who has an idea of a description?
Two systems of equation matrices that have this solution.
Well, this isn't even limited to just like systems of equations. Let's just talk about matrices in general. Okay. What has to be true about the orders of A and B if they're equal? They have to be the same. What has to be true about the entries inside A and B? They have to be the same, okay? They have to have the same order with the same entries. Okay. Now, what we'll discuss before lunch is matrix addition. What do you think has to be true to add two matrices together? Darby? Order. Hey, matrices have to have the same order if we are going to add them together. If they have the same order, then all we have to do is add the corresponding entries. Okay? If they do not have the same order, then we say that their sum is undefined. So if two matrices do not have the same order and I'm asking you to add them together, you say that the sum is undefined. Okay. And like I said earlier, we're just going to add corresponding entries. We'll go through an example of matrix addition. The description, pretty straightforward. We add like entries together. Okay. Now, the second concept that we're going to practice on the next slide is what we call scalar multiplication. A scalar is like a number, 2, 4, 6, 8. If you have a scalar multiplied to your matrix, then every single entry gets multiplied by that scalar.
So it's like, it becomes like a multiple of the matrix.
Correct. To be honest, what's going to take us the longest is writing down our problems. Scalar multiplication is just going to be a number times one matrix, so the order is not going to be a big deal. Matrix addition, orders have to be the same. We add like entries together. All right? So on the next slide, there's going to be two matrices, A and B. Please write them down, and then we're going to do like 3 different things with matrix A and B. Okay? So go ahead and write down matrix A and B. is the order of matrix A? Mm-hmm. Like how many rows, how many columns? There you go, 3 by 3. Okay. And the order of matrix B, what is it, Connor? Do matrix A and B have the same order? They do, which means we can add them together, which is what we're going to do. If we are going to find A plus B, we are going to have a 3 by 3 matrix, where for our first entry in the first row, we're going to take 2 plus 2. First row, second entry, 2 plus 0. Third entry, 4 plus 0. Oh, yep, sorry. And then we're going to move to the second row. Negative 3 plus 1, 0 plus negative 4, and negative 1 plus 3. And we're going to move to the third row. 2 plus negative 1, 1 plus 3, and 2 plus 2. Like I said, what's going to take us the most time is writing down the problem. Okay? Questions? All right. Your calculator can do this, but I don't say you to do it. Okay. It'll take too much time to type everything in, right? All right. Now I want to find negative 2b. Negative 2 is a scalar that we're going to multiply to b. To find negative 2b, we're literally taking every single entry in b and multiplying it by negative 2. So negative 2b is negative 4, 0, 0, negative 2, 8, negative 6, 2, negative 6, negative 4. What? You're enjoying this?
Yeah, and then I know it's gonna get hard and do something really hard.
Well, I won't make it difficult until after lunch, and it's really not that difficult.
Until after.
Don't worry, don't worry.
Oh, like 2 minutes. Well. Okay, now we're going to find 3a minus b. Okay, my suggestion to you would be to not do too many steps at once. Since we are finding 3a minus b, I think it would be in our best interest to figure out what 3a is and then subtract b. So, (3a), help me out. What is our first row for 3a? Huh? 6, 6, 12. What's our second row? Negative 9, 0, negative 3. Okay. 6, 6, 3, 6. And we are subtracting 2, 0, 0, 1, negative 4, 3, negative 1, 3, 2. If you are worried about forgetting the subtraction, you could always make this a positive and multiply a negative 1 scalar through. I don't think it's necessary, but if you're worried about messing up a subtraction, you can do that, okay? But now we just need to subtract all of our entries. So 6 minus 2, 6 minus 0, and 12 minus 0. Second row, negative 9 minus 1, 0 minus negative 4, negative 3 minus 3. And then our third row, 6 minus negative 1, 3 minus 3, and 6 minus 2. Make sure you put the brackets around your matrix so I know that it is a matrix. This is nice, isn't it? Okay. Now, matrix addition, very straightforward. Matrix multiplication, not as straightforward, but not complicated, okay? What I first want you to write down is this. If A is an M by N matrix and B is an N by P matrix, then the product AB is an N by P matrix. I want you to just write it down, and we're going to sort through what that means after lunch. Okay, when you have this written down, you may go to lunch. When we come back, we'll sort through it.
This one, can I have you sign this for Leadership Academy?
Okay, so what does this mean? Okay. When we are multiplying two matrices, their order has to follow this rule. So it says A is an M by N matrix, and B is an N by P matrix. So what has to happen is that those have to match. If those don't match, we can't perform the multiplication. Okay? So the columns of the first have to match the number of columns. Let me say this again. The number of columns in the first need to match the number of rows in the second. Okay? And then the product is going to be M by P. What's on the outside? Now, there are going to be a lot of words written up here, and I don't want you to write all of them. What I want you to write is that matrix multiplication is row by column multiplication. And that's why we need to have our order match up the way that it does. Okay? We're going to take a row and multiply it by a column. Okay? And we're going to sum up those numbers together. Okay? And depending on which row and which column we multiply will tell us where in the matrix it's going to go. So if we multiply the first row by the first column, that number will go in the first row, first column. If we take the second row times the third column, that entry is going to go in the second row, third column. Okay? So what I need you to do is write down AB equals A times B. Okay, I want you to write down that product for me. So what we're going to do is we're going to take row times column, and we're going to multiply the entries together and then sum them up. Okay, sum means what?
Addition.
Addition. Okay. So, first of all, let's talk about the order of these matrices. What is the order of A?
3 by 2.
What's the order of B? 2 by 2. Okay, do these numbers match up? Yes. And this means our resulting matrix will be a 3 by 2. Okay. So what I would do is I would say equals and make a big matrix for 3 rows, 2 columns. Make big so you can fit all these numbers. Okay. Now, we're going to go through this slow, and we're going to do another example. Okay. So what we're going to do is we are going to take row times column, and you're going to take these numbers and match them up with these two. Okay. So for your first row, first column, which is right here, you're going to take -1 times -3 and add it to 3 times -4. Then you're going to take the first row times the second column. That number is going to go in the first row, second column. And you're going to match these two numbers up with these two numbers. -1 times 2, and you're going to add it to 3 times 1. What, Gabe? Are you talking about this right here?
Yes.
Okay. Because we took first row times first column, so -1 times -3, 3 times -4. You're going to multiply your first row times each of your columns. Once we get to the last column, then we can move to the second row. So that's what we're going to do. We're going to take the second row times the first column, and we're going to put that number here in the second row, first column. Okay. We're going to match up pairs of numbers, so 4 times -3 plus -2 times -4. Then we're going to move to the second row, second column. That entry goes in the second row, second column. We take 4 times 2 and -2 times 1. Do you see how we're matching up those pairs of numbers to multiply? Then we can move on to the third row. So third row times first column is going to go in the third row, first column of our product matrix. So 5 times -3 plus 0 times -4. And then we will do row times column. Third row, second column goes here in the third row, second column. 5 times 2 plus 0 times 1. So then we can actually multiply those products, add them together. So you see -3 times -1 plus 3 times -4 is -9. -1 times 2 plus 3 times 1 is 1. Exactly. Some of you may feel like, oh yeah, this isn't too bad. Some of you may feel like this is a little bit overwhelming right now, okay? It can only get better if you practice it. If you do not practice it, you do not have a very good chance of doing it correctly on your problem set this weekend and your quiz on Monday, okay? You have to practice, right? So this is the one that we are going to practice together. Please write down A and B. Jacob, what's the order of matrix A?
2, 3.
Okay. Matrix A is a 2 by 3. Matrix B, Kelsey, what's its order? Can we multiply these two together? We can, and our result is going to be a 2 by 2. So a 2 by 2 matrix has 2 rows and 2 columns. Okay. So row by column multiplication. First row, first column. What is 1 times negative 2? Plus 0 times 1. Plus 3 times negative 1. So our first entry is negative 5. It would be my advice that you show this step right here instead of just multiplying and adding all of those numbers in your head to get the negative 5. Okay. Then we will move on to first row, second column. Let's do those products. 1 times 4 plus 0 times 0 plus 3 times 1. So our first row, second column entry is 7. We ran out of columns, so we're going to move to the second row. First column. What is 2 times negative 2? Plus negative 1 times 1. Plus negative 2 times negative 1. So our second row, first column entry is last but not least, second row, second column, we have 2 times 4 plus negative 1 times 0 plus negative 2 times 1. So that gives us a 6 for the second row. Questions? 30-second conversation with your pod. Is matrix multiplication commutative? Commutative means A times B is the same as B times A. 30 seconds, go.
I'm still no idea.
if you had like the order 2x3, and then another one was like a 3x4. So like that, but then if you, and like that was A times B, but if you wanted B times A, it'd be 3x4.
All right,
3.
pod 3. What you got for me? Pod 3 says no. What?
Because if you switch them around, like those two, it'd be a 3x3, not a 2x2.
Okay, so we said that this was a 2x3 matrix and this was a 3x2 matrix. So these matched and we got a 2x2 out of the deal. Darby is saying if we took B times A, we're taking a 3x2 matrix times a 2x3 matrix, which means we're going to get a 3x3 matrix. Obviously not the same thing. Okay? It's actually kind of a special thing that you can even take B times A. Not all the time will we even be able to take B times A because the columns and rows won't match up the way that we want. Okay? So, multiplication with numbers, commutative. Multiplication with matrices, not commutative. Okay? That's important to understand. Okay. You are going to get problems where you will have multiple operations in one.
Let me just use half the page.
Okay. Let's talk about this one. What should we do first?
Multiply. This sacrifice, whatever it was.
Okay, we should multiply our matrices first and then worry about the constant, the scalar multiple last.
Scary.
Can we multiply these two together?
Yes.
Unfortunately,
Maybe I'll put this one. Is that a 3 at the top?
we get a 2x2 matrix. Okay, so some of you've already started to do the multiplication, that's fine. If you want to follow me, you can follow me. First row times first column, we have 6 times 0 plus 5 times -1 plus -1 times 4. Okay. First row second column, we have 6 times 3 plus 5 times -3 plus 1 times -1. Second row, first column, we have 1 times 0 plus -2 times -1 plus 0 times 4. Second row, second column, we have 1 times 3, -2 times -3, and 0 times 1. Questions on any of those values? So what we have is -3 times the matrix, -9, 2, 2, 9. Oh, that's nice. Okay, Henry, what do we get when we take -3 times this matrix?
You get 37, -6, -6, -37.
Excellent. What? Okay, I'm going to take a couple minutes and show you how we could set up more of an application problem with matrix multiplication. Okay. We have 2 softball teams and their equipment lists, and I'm telling you how much each equipment costs. Now, you know that to figure out the women's team, you're going to take 12 bats times how much they cost, plus 45 softballs times how much they cost, plus 15 gloves times how much they cost, and add them all together, right? Yeah, I mean, you know that you're going to do that, okay? But we're going to let the matrices do that for us, okay? So we're going to take this table right here, and we're going to make it a matrix, where we have women's and men's bats, balls, and gloves. Okay. And then we have 3 pieces of information. We have how much the bats, balls, and gloves cost. Okay? Should we create a 1x3 or a 3x1 matrix? What do you say, Darby? A 1x3? Okay, where we have how much it costs for a bat, ball, what was it? And glove. I already forgot how much it costs. 6 and 60. Okay? So now notice, when we take this multiplication, our 1x3 times a 3x2, these match up. That's why we had to write it as a 1x3. And watch this. Our row times column multiplication, those labels match up. And we are going to be left with how much it costs for the women and the men's team. I mean, it's basically doing what we would do without a matrix. But the matrix multiplication is just putting it all together in a nice table organized fashion. Okay, so we're still taking 80 plus 12, 80 times 12 plus 6 times 45 plus 60 times 15 for a total of 2,130. And then we're still going to take 80 times 15 plus 6 times 38 plus 60 times 17 to get a total of $2,448. Unfortunately, it's Wednesday, so we have like less time than other classes in 5th hour. I don't know why that happens Wednesday, but you guys have less time in here. So I'm sorry that I kind of tried to push through that, but I need to talk to you about some things. First thing, you have to practice matrix multiplication. Okay, you do not have very many problems in your homework. Okay, if we look at your gold sheet, okay, really not that many. Okay, you have to practice. Now, tomorrow, I am not going to be here. I'll be here in the morning, so if you want to come see me in the morning, you can. But I will not be in your class. Okay, there will be a video that a math teacher will play. It's actually going to be for your class, and he